As with everything else on the AWS platform, you'll find that you have a lot of choice. And when it comes to databases, AWS gives you a lot of options. So for starters, you have the traditional relational database services, right? You have then non-traditional RDS or relational database services. You have in-memory type databases. And for this one in particular, there's a product called Elasticache, which is essentially an in-memory cache database, very, very fast type of database. You have Redshift for data warehousing. That's a petabyte scale type data warehousing database. That's how large this type of a database can be. And then you have custom. So what custom means is if you don't want to use any of the managed services, any of the managed hosted database options that you have with RDS and non-RDS, and you simply want to maybe, put up your own operating system and install your own database software on it, maybe it's Microsoft SQL, and you want to go through that installation and manage it and maintain it yourself, then you absolutely can do that. So those are all the database options that AWS provides, and we're going to dig into some of them. The in-memory and the data warehousing, it's a little outside of the scope. I just wanted you to be aware that as far as in-memory caching is concerned, that's the Elasticache. As far as data warehousing is concerned, that would be the Redshift. And as far as custom, that's again something that you're used to. That's something that you've done many times in the past, where you're installing the operating system, you're installing the database software, and then you're managing and maintaining it. What I want to focus on here are RDS and non-RDS. Now, for more information on running databases on AWS, I've also provided you with a link that essentially takes you to the starter page for AWS Database Options. Let's first talk about Amazon RDS options. Now, for those of you that don't know what RDS stands for, that's Relational Database Services. Now, this is the traditional type of databases, right? This is where you have a structure for the database, where you have tables, and these tables are linked to other tables. It's a very structured type of approach to a database. And you'll find that most of the popular databases, at least from a vendor perspective, are, fall under the RDS option. So for starters, you'll find that you have an option as far as MySQL is concerned. You'll have Oracle, again, a mammoth as far as databases are concerned. Microsoft SQL, again, one of the most popular types of databases out there. You have PostgreSQL, also, again, a type of RDS server. And finally, you have Aurora. These are the essentially 5 types of RDS options that Amazon will support when it comes to RDS. And then you have non-RDS. Well, Eli, what's non-RDS? Well, it's exactly the opposite of RDS. While RDS is very structured and you have tables and everything is organized and follows rules, non-RDS, think of it as a flat file, essentially. Everything goes into one table, everything goes into one file, and it's up to the software to kind of make sense of it. So as far as non-RDS options are concerned, Amazon offers, you have SimpleDB. Now, SimpleDB is a very highly available, very scalable managed database service that Amazon offers. Now, this is typically good for databases that aren't going to grow beyond 10 gigabyte. And then you have the more popular option on Amazon, which is DynamoDB. DynamoDB is a very fast, very scalable, very reliable database. Again, it's a NoSQL essentially. They're both, all of the non-RDS are based on non-SQL or NoSQL, which is funny considering the other ones are all SQL. And SQL, by the way, is not a Microsoft product. While Microsoft kind of popularized the term SQL, the SQL database is not really a Microsoft term. It's an industry term that refers to a specific language. So when you say NoSQL here for SimpleDB, DynamoDB, and some of the other options that I'm going to show you, that just means that they're not following that structure that I was talking about. They're not following these policies and rules. They're putting all of these things in one file, and then the software, the intelligence comes from the software as far as how to handle this. Now, the reason they put everything in one file is because it's much faster to query. It's much faster to index as opposed to having all the data in different tables. And then when you want to query, you have to go through the different tables. And then you have linked tables that you have to go to those as well. When you have everything in one file, you're able to crawl it, you're able to index it, you're able to query it a lot faster. Hence why the claim to fame to a lot of these non-relational database services come in. Now, these are the 2 managed services type of non-RDS databases that you can get access to with AWS. But you also have things like MongoDB or things like, for instance, Couchbase. And both of those are supported in the custom field. Now, when I say supported, Amazon specifically mentions some of these third-party databases. And again, you have to double check always for some of this data to make sure that it's up to date, because things change frequently. But those two databases are spelled out specifically with Amazon, that they are AWS friendly. They have hooks into AWS. That doesn't mean that you couldn't, again, stand up your own instance and install whatever type of software that you want. So again, these are the non-RDS type of databases that are supported with Amazon. Now, without further ado, instead of me just continuing to talk about it, let me show you where you would go into the management console and where you would be able to configure a database, just to give you a feel for what it's like to configure a database on AWS. And while I'm doing this, what I want you to do is compare that with what it would take you to configure and install a database on premises, right? What I want you to do, and just for simplistic sake, and most of you have probably done this before, I've installed Microsoft SQL many times, right? And most of you probably have done the same thing. So what we're going to focus on in the example that I'm about to show you is how to configure a SQL instance on AWS. As I'm doing this, think of what it would take you to do the same thing on premises. Think about it from a time perspective, how long it would take you, from an effort perspective, from a patching and security perspective, from a high availability perspective, from a synchronization perspective, replication perspective, all of the things that Amazon is offering you as a service, which means you no longer have to patch it, you no longer have to maintain it, you no longer have to worry about HA and scalability and all of that stuff. They're doing all of that in the back end. So think about that effort, all the money for the hardware, for the software, for the maintenance, for the patching. Think about, I want all of these things to be going through your mind while we're doing this. From the management console, what we want to do is under databases, we want to click on RDS. This brings us to this particular screen. Now, again, I haven't created any kind of instances before, so I get the get started type of screen. Otherwise, it would have probably dropped me into kind of the overview or the dashboard here. But for now, the dashboard for me looks like this. So let's go ahead and create our first instance. So what we're going to do is click on Get Started here. And then you have the option of selecting the type of relational database that you want to configure. Now, I'm going to go ahead and select SQL. And the thing to note here with SQL Server as we start to go through this is when it comes to some of these applications, anything above the operating system, essentially, you have the option of bring your own license. Anything below the operating or below the application level, so operating system and below, you cannot put your own license when it comes to AWS. So you can't bring your Windows Server 2012, for example, operating system license and plug it into your instance. But you can bring your SQL Server license, and I'll show you when we're going through this wizard where that comes into play and where you can plug it in. But just keep that in mind as we're going through this, just so you have an idea. So you have the Express version. This is the free version. You have the web version. And you have the enterprise version, and for these, you're going your standard edition, your enterprise edition. For these, you're going to have to bring your own license, especially for this one, I believe. But let's go ahead and go with a standard edition and see what the wizard looks like. Again, I want you to be thinking about comparing this process to what it would be if you were doing this with on-premises. So I'm going to go ahead and click on Select. The first thing that you're prompted with here, and this is really cool in my opinion, do you plan to use this database across multiple availability zones? Do you want it to be deployed across multiple availability zones, or do you want this to be deployed across a single availability zone? Now, again, I know you guys probably know this. You should know this by now because I've made you experts on AWS. But an availability zone is a data center, remember? So I want you to also think how easy it is. It's a radio button here. Hey, do you want to deploy this across 2 data centers, or do you want to deploy this in 1 data center only? So again, think in the back of your mind, what it would take for you to stand up both of these SQL servers. Am I going to put replication? Am I going to do mirroring? What type of link do I have to worry about? I want all of these things to be, and think, how long will it take me to do this? How long will I get hardware in there? Remember, this has been, what, a minute or two that we've been doing this. So I'm going to go ahead and select yes for multiple availability zones. I'm going to go ahead and click on next. And this is where you get to the point where now you're configuring your database. Now, again, continue to compare that with how long it would have taken us if we were doing this on our own to get to the configuration part, right? So the database engine is selected already. This is based on previous options that we've made. The license model. So from the license model, from the drop down here, you have the option of bring your own license, or you can consume a license as part of the price that you're going to pay. So as far as I'm concerned, I want to make sure that my license is included. I don't want to have my own license. You have the database engine version that you can select from here. I'm just going to leave the default. The database instance class, again, this is where you select the number of vCPUs, the number of RAM. So again, just to keep things simple and cheap for me for right now, I'm going to go ahead and select one vCPU. Not ideal, obviously, for a SQL server, but again, you guys get the point. And here we're doing a multi-zone or multi-availability zone deployment. Yes, and it's going to be doing it via mirroring. Again, you can select no from the drop-down menu if you want to change your mind. If we scroll a little down, now you have the storage type. So remember, this is, again, here it's putting it on general purpose SSD. From the drop-down menu, you can select other options if you wanted to do so. I'm going to leave it at the default. I'm also going to leave the storage capacity at the default. Now, as far as the database instance identifier, you have the option here, again, of selecting whatever you want. For us, let's just do, I don't know, wired brain. And then you have your root username and you have your root password. So as far as master username, well, let's just do root for now. And for password, I'm going to go ahead and enter a super secret password here. And then when you're ready, we're going to go ahead and click on next. And as you're going through and progressing with this, you'll see that on the left here, it's telling you kind of the steps that you need to take and where you're at in the process. And again, just think about how simple and easy this is and how seamless this is and how quickly you can get to the point where you're already up and running. You're giving this database to either your database administrator or to the application owner so that they can begin to do actual work on it. Now, here's where you can configure your network and security. You select the VPC. If you had multiple VPCs, you would select the one that you want to drop it into. For now, I'm going to leave it at the default. As far as subnet group, again, you have the option of selecting, if you had subnet groups configured in here, you would select that. I'm going to keep it at default. Publicly accessible, yes or no. Again, that will depend on what you're doing. Again, I'm going to go with all the defaults here. Availability zone. If you had a preference for availability zone, this is where you would need to deploy it. Make sure this is accessible from your instances or the applications that are going to connect to this database. So for me, I'm just going to say no preference at this point. VPC security groups, again, you have the option of selecting the VPC security group that you want, and you can keep scrolling down, right? These are the database ports. This is the parameter group, the option group. You're enabling encryption or you're not enabling encryption, whether or not you want to back it up and how often do you want to back it up. So again, here they're doing, it's had a retention period of 7 days, or you can choose, up or down depending on what you want here. Your backup window, you can select the window or no preference if you don't really care when you want that to be backed up. So I'm just going to leave it at no preference. Maintenance. Do you want it to do automatically upgrade minor versions? So if there are minor versions, do you want that to be upgraded, yes or no? If you have a preference or a maintenance window that you want to put in here as far as what time, what day of the week, etc., you can select those as well. Again, all of this stuff you should be familiar with. And if you're not familiar with, your database administrator or your application owner should be able to give you a lot of these instances. Now, once you're ready, it's as simple as bada bing, bada boom, and we are going to be up and running with the database instance in no time. So my database instance is being created. At this point, I am done. So I can see essentially here my database instances. So I'm going to go ahead and click on it. It is still in the initialization phase. If I come back up here to the dashboard, now the dashboard is kind of familiar to what the dashboard looks like with, for example, EC2 that you're used to, and you'll find that you have, quick links to, your running databases, your instances, etc. So if I click on the instance, it's up and running. Now you can point all of your applications to this database instance that are, that are running on Amazon, for example, or on AWS. The takeaway here is the simplicity. It's the ease. We just deployed a database, folks, across multiple availability zones with mirroring configured between them in probably less than 10 minutes. I don't know where we would be at this point as far as on-premises, maybe even in the planning phase. So this is the ease. This is the value add that I want you to take away from the cloud is how long would it have taken you to do this? At what cost? What's the ongoing support? The backup? All of that was built into a couple of clicks that we went through. That is the power of what AWS brings to the table. The Amazon APIs. Now, we've talked about APIs in probably almost every module that we've recorded. Now, API stands for Application Programming Interface. If we were to slap a definition around it, it would be an application-to-application communication method. Now, Eli, what exactly do you mean by an application-to-application communication method? These are developer tools, right? These are developer capabilities that I'm not going to delve very deeply into them. But what an API is, it's essentially a communication method that allows you to communicate with any of the services on AWS. So take, for example, S3. You could write an application, maybe like Dropbox. A perfect example of that would be Dropbox. Dropbox is an application that interfaces with S3. So every time a user stores a file on Dropbox, that file is stored on S3. Every time there is a delete command that is made, Dropbox is issuing that delete command to the S3 platform via the API, and so on and so forth. If you wanted to launch an instance, for example, on EC2, you could write a front-end application through the API that interfaces with it and launches that EC2 instance. You could do the same thing for Glacier. Actually, Glacier is a perfect example of how you can use as a target for backups, for instance. If you have a front-end application that is doing the backup, it can interface to Glacier through an API and do your backups or store your files that way. So it's an application-to-application communication method. Almost every AWS service is API capable. If you go on Google, and Google knows everything, right? And you're putting S3 API, you're going to get the documentation for the APIs. And I'm not gonna go through that. It's, again, a lot of code, a lot of language that's beyond the scope of this course. But if you're a developer, then you're in heaven, right? Because there's an API for every service that Amazon offers. So, go crazy with it. Search for the EC2 APIs, the S3 APIs, the databases API. Again, an API for pretty much every service that's out there by AWS. They also offer API wrappers. Now, again, those of you that are developers probably know what an API wrapper is. I'm just going to go through this very quickly for those that aren't. The reason I'm bringing this up is if you're a developer, you should be aware that there are wrappers that are available out there. Now, what is a wrapper? A wrapper allows Amazon to simplify things for you. So if you're writing things in iOS or in .NET, the wrapper will kind of be that translator, and then the commands that are actually issued are actual AWS commands in the language that AWS understands. So AWS again provides these wrappers to the developers to make the process easier. So if you're coding against a particular platform, it's taking that and sort of translating those commands into AWS type of commands. So again, it makes things a little easier and a lot faster to go through. Now, API authentication. Recall when you're creating an IAM user, for example, you're issued a set of code, right? A username that's a set of alphanumeric numbers, and then you have a secret code that's, again, a long string of alphanumeric numbers. That's how you can not just log in or use the AWS platform through a username and password, for example. You can use it through an application. So if you wanted a particular application, like let's take Dropbox because we talked about it. In order for Dropbox to be able to have permissions to place files, remove files, edit files, it needs to happen through some form of authentication, and that's where you can plug in those numbers that will allow the application to authenticate. So again, that's the API authentication. So developers will typically use API authentication when they're writing applications in order to get the right permissions to do a particular function. Are you ready to have your mind blown away? I'm about to tell you about a really, really cool service from Amazon called Lambda. When I was first introduced to this service, I was like, wow, this is pretty cool. And while this is geared a lot towards developers, I was even impressed with it, and I'm an infrastructure guy. But it was really cool because you can understand the concept. You can understand the power of what you can accomplish with something like Lambda. Now, while Lambda is a compute service, and we're talking about databases and APIs here, I just found that it kind of fits the particular subject that we're talking about perfectly in this module. And as I go through it, I'm hoping that you also agree with me that this is the perfect location to talk about Lambda. So what is Lambda? Lambda is a compute service, but it's not just a compute service. It's an event-driven compute service. Eli, you're not making sense. Well, so what an event-driven compute service means is that you're able to take action against an event. That event could be any number of things. It could be maybe a file that got created on S3. As soon as that file gets created, an event gets triggered that, hey, a file was created on S3, and as a result, you can have code run immediately and do something with that particular file. And we'll give examples in a second. But the idea here is that you can run code against something that happens, a trigger of some sort. That trigger could be event driven, and it could be data driven, and we'll talk about some of the examples. But again, it's a service, it's a compute service essentially that allows you to run code against an event. So it runs code triggered by events. It does not require an instance. This is the beauty, this is the secret to this particular service, why this service is so valuable. It doesn't require an instance. Well, what do you mean, Eli? Well, I mean it doesn't require a VM. It doesn't require a server. Well, how's the code going to run? Well, that's the beauty of it, right? So the code is running against a compute platform. So instead of having a server, think of the server here as a huge platform where Amazon allows you to run your code against that platform whenever an event is triggered. Now I know it's getting clearer in your mind, but it's not 100%. And I was in the same place when I was kind of reading and understanding this. So as I start to give you examples, this will get clearer. So just bear with me for a second. So again, the idea here is it doesn't require an instance. It doesn't even require an infrastructure. Well, what do you mean? Well, I don't need servers. I don't need all the prerequisites that come with servers in order to run my code. Now, being able to react to an event-driven trigger of sorts is not new. We can do that today. The question is, how can we do that today? What is required for us to do that today? And I'm going to show you all of that in a second. The idea here is they are simplifying how we react to an event, how we react to a trigger. They are simplifying it to the point where this is like, wow. And they're doing that for a lot of different reasons because the technology requires it. But I want you to, again, stay with me for a second. So it does not require an infrastructure. It's rapid response to events. You're talking 2 milliseconds or less response time to an event. As soon as that event is triggered, you're able to respond with whatever code you see is necessary to take action. You can do thousands of functions that can run in parallel at the same time. So you can have one function that's running against one particular event that got triggered, or you can have thousands of these functions that are running at the same time. So it's a very scalable environment. And you run it only when needed. That is the beauty of it. So again, outside of everything else, if we wanted to do this today, we would have to stand up an infrastructure. But that infrastructure wouldn't be run it when you need it. That infrastructure, once you stand it up, it's going to be up, right? The beauty here is you take your code. When the event is triggered, you run your code. You pay money for that, obviously. When there's no event trigger, guess what? You don't pay anything. Your code's not running. That is the beauty of this platform. So start thinking about it. It's a compute platform. When I was listening to this, you know what came to mind immediately? Our Spot instances. I'm like, this sounds, why wouldn't I use Spot instances for it? This goes beyond that. Yes, you can use Spot instances probably to do something like that because you need, these pools of servers that will be able to run code for you when you want. But the idea here is you don't even need that. You don't have to maintain those. You don't have to install code on them or update them or worry how to deploy to them. It's just a platform. Worry about the code. You write the code, execute the code against that compute platform. The compute platform will run when needed. That's the beauty of Lambda. Let's take a look at some use cases. Now, again, I'm going to take very simplistic use cases. Well, for a couple of reasons. First of all, I'm not a developer. And second of all, I wanted things, that don't take us into the weeds. Things that are going to be easy to understand. It's a simple example. Again, as a developer, if you're a developer watching this or listening to this, you can go crazy with this and go, ballistic, go as deep and complicated as you want. But for us, these are probably going to do. So if you have, if you have a photo sharing website and what you want to do is as soon as an image is added to an S3 bucket, you want to be able to create a thumbnail out of it. Not too complicated, right? You could probably do that today. And that's one example, right? One use case. Another use case is that, maybe you have an application that stores addresses in Amazon DynamoDB. Well, maybe you want to check every time a new address is added if that particular address is well formed. Again, very simple use cases. Now, we can do these today. Let's take a look at what it would take for us to do this today? What kind of infrastructure, what kind of operations am I looking at to accomplish these very, very simple tasks that I just laid out? So before Lambda is the title that I chose for this slide. And the reason for that is if you wanted to, for example, use the example that I gave with creating thumbnails for images as soon as they're dropped into S3, well, you would have to provision a fleet of proxy machines to capture the uploads. That's the first thing you're going to need, right? So you're going to need a bunch of machines that capture that upload. For each upload, you're going to have to enqueue a job and then process it, right? Now, you're going to have to provision a second fleet of machines in order to read and process the job. Now, keep in mind how many machines we're talking about here. It could be as little as 1 or 2, or it could be 10, 20, 200. So regardless, the process is the same. As a developer, you shouldn't care about infrastructure. You don't have to worry about infrastructure. All you care about is your code. Now, you also have to pick a deployment solution, right? How am I going to deploy my code? How am I going to update my code? You also have to worry about capacity. Do I have enough servers? Do I not have enough servers? How many servers do I need? What's my long-term utilization? Can I burst? Which means, are you going to have to over-provision? How quickly can you provision? Now, the good news here is if you're using auto-scaling and you have your code on AWS, the question of burstability becomes, we self-answered that, right? Because I can auto-scale, grow, and shrink the environment as I need. But outside of the growing and the shrinking, you still have operational requirements in order to manage this. You still have to plan for capacity, right? Autoscale is helpful for shrinking and for growing the environment, but it's not a long-term strategy. You still have to have some kind of a baseline of instances that are created. Now, you also have to monitor these instances, and you have to monitor them on a 24/7, 365-day basis, depending on the criticality of the application and the code that you're deploying. Someone has to do that monitoring of the infrastructure. I'm not even talking about monitoring of the code or anything like that. Someone has to monitor these servers. Someone has to patch the operating system. Someone has to patch the databases. Someone has to make sure that you're able to migrate from instance to instance whenever maybe a new type of instance comes out. So after 3 years, how am I going to migrate my application, my code, onto new instances? All of these are challenges, they're operational challenges that as a developer you shouldn't have to worry about. But all of that aside, think of how long it would take you to build this environment and get it to a point where you can run your code against it. And take into account the stages that you have to go through, right? So you have to build the environment, you have to test the environment, and then you have to release it into production. Well, here comes Amazon saying, you know what? You don't need any of that. You don't need this infrastructure environment. You're a developer. Give me your code. Your code will be executed against a compute platform. So what you care about here is a compute platform, right? You want that computing power so that it can execute. I will give that to you. Let me handle all of the rest of this stuff in the background for you. I will monitor it. I will worry about patching. I will secure the operating system. Don't worry about the migration. Don't worry about the provisioning of a second fleet or even a first fleet. Just worry about your code. Beautiful, beautiful service by AWS. All right, so it's an event-driven compute. So what does that mean? So it's stateless, request-driven code called Lambda functions. So again, these request-driven codes are called Lambda functions, and the reason I want you to remember this is because if we reference them, you have to remember that they're called Lambda functions essentially, and they're triggered by events. And events could be simple things like you're putting something in S3. That's putting a file in S3. You're writing something to a Dynamo database table. You're doing a transition in EC2 state instance. You're doing a message from a simple queuing service queue in Kinesis, for example. Any API call or resource transition. So again, all of these are triggers, but again, let your imagination run wild with what you can do with this thing. And finally, this is a sort of connective tissue, and that's why I called it a platform. This language comes from AWS. It's a connective tissue for all AWS services. And what that means is you can use Lambda across all of the AWS services to make it more active, to bring it alive. I don't know if it's in your mind, the Internet of Things is coming to mind as where something like this could be useful. And if you're thinking about that, then you're going to love the second slide, because absolutely you can use something like Lambda for the Internet of Things. So let's take a look at what we can use it for. So we talked about server-free backend. We killed that one, right? We talked about that one to death. You don't need a server backend of any sort. You don't need an infrastructure of any sort to be able to run your code. So that's one use case for it. You can use it with any kind of data triggers. These data triggers can range from things that are as simple as placing something in an S3 bucket to the EC2 instance change to a notification going off. Anything that would trigger an event can be used against a Lambda function. Internet of Things. Can you imagine what you can do with this platform with the Internet of Things? If you have your sensors, and these sensors can be as simple as temperature changes, that's an event that gets triggered. And I don't know what type of action you would want to take against a temperature change, but that depends on what you're using the sensor for, right? If the sensor is maybe used for protecting food, then, well, maybe that particular event will trigger notifications that go out to the right people to say, hey, your meat is about to get spoiled because the temperature dropped by 10 degrees. Just an example of what you can use this for. Or maybe, if you're in a, for safety reasons, if there's a sensor in the car and someone gets into a car accident, that automatically triggers a call, 911 call, or a call to the ambulance or to the police or fire department, whatever. So there's a lot of ways where you can tie the Internet of Things with a platform like this. You also have stream processing, so you're able to leverage this for stream processing these types of functions that would require this type of functionality. And you can use it for indexing and synchronization. Again, a large portion of AWS customers will use the platform for indexing and synchronization type services. Again, you can use Lambda to address some of these issues as well. Now, at this point, I'm pretty sure you're wondering, well, how much does this thing cost? And I'm going to show you some really cool pricing as far as the Lambda is concerned. So it's based off of a number of things. The first thing is the number of requests, and the number of requests is per million. So it's essentially 20 cents per million, essentially. And then it's also based on execution time in 100 millisecond. And I don't know how many zeros or how to read this. I just know that it's a 0 dot. There are 6 zeros behind it, and then a 21. So execution time in 100 milliseconds. Hopefully the developers that are watching this understand this a little better than I do, as far as what this means exactly, because to me it really doesn't mean much. And then finally, it's the amount of memory, and the amount of memory is calculated also 100 milliseconds at 128 meg. Again, we're starting to go into territory here that's a little interesting, but I wanted to put that out there. Now, Lambda is also available as part of the free tier. As part of the free tier, you get 1 million requests and up to 3.2 million seconds of execution. So again, you're getting something in the free tier that you can use this particular service. And I don't know if these numbers are good, are low, or are high. Again, you would need a developer to say, yeah, you know what, 1 million requests, that's really not a lot, and 3.2 million seconds of execution is not a lot. For me, I'm like, oh, it's a million, so it's got to be a lot. But again, at least they're offering you something in the free tier that you can get started with. So you like it? What do you think? Good module? I think so. So let's recap what we've learned. We started off by talking about the different Amazon database options. We talked about the fact that Amazon offers RDS, relational database services, non-RDS, which are the non-relational database services, or anything that's NoSQL, essentially. We also talked about the in-memory cache type database that they offer, the petabyte scale warehousing database, and also the fact that you can bring your own database, right? If you still want to load the operating system and install your version of SQL or Oracle or whatever, MongoDB on that particular instance, feel free to do that. Amazon will support that all day long. We also talked about the fact that with RDS, you have several different options, from Oracle to Microsoft SQL to MySQL to Aurora. So you have different options there. In the non-RDS, you also have SimpleDB, you have MongoDB, you have DynamoDB, Couchbase. You have several different options there that are supported as well. I took you through and I showed you within the management console how to provision a database and how quickly that is, how easy that is to go through that. We also talked about the Amazon APIs. We talked about the fact that almost every service on AWS has an API. It's an application programming interface. Essentially, it's an application-to-application communication language, which means an application can issue or can leverage the APIs to execute a certain function against a service on the Amazon platform. Talked about how you can use APIs for authentication as well. We then talked about Lambda. Lambda is probably, it's climbing the charts as far as my favorite Amazon Web Services service. And it's essentially a compute service. It's a compute platform that allows you to run code against that platform without the need for an instance, without the need for an infrastructure. And the beauty of it is that you can run this code when you need it, and you pay for it when you're using it. So as opposed to standing up an environment and then using it sometimes and not using it a lot of times, with Lambda, you have the code, and that code is executing against the platform. It's a compute platform, and it executes against events that are triggered by any number of reasons, right? So that's where the power of Lambda comes into play. Finally, I hope you enjoyed this module, and I'd like to thank you for viewing.